Assalamu alaikum, good evening. This is Jakir from Dhaka, Bangladesh. We are here to discuss water chemistry. Today is our 22nd class. We have finished 21st class yesterday. Every day we start at sharp 10:30 p.m. at Bangladesh time, and we try to finish at 11 p.m. So I'm waiting you all to connect. It's a live class. So I like to have you all connected, then I will start my discussion. Today we will discuss on very important topics, effects of water on different system process. And as per schedule, today is 10:30 p.m. We will start, and definitely I'm waiting to connect you all. And thank you and welcome you all to be on connected, and this is very grateful and pleasure for me that you are encouraging me regularly, you are connecting me regularly, you are helping me, you assist me, and you are encouraging me to learning new things. And I like to share my experience of last couple of years, and more than around 15 years I'm working in water chemistry. So it's a very nice and free discussion on truly the pure knowledge on water chemistry. Thank you all who already connected. I also like to connect, have more people, and I'm sure you are all in very good in mood, but still I like to share music for you all so that you can enjoy it, and I'm waiting to connect more people to discuss today's topic. Mahbubul Alam, Asif Iqbal, thank you. I'm waiting to connect more people, and by the time I like to have a song, I keep a song for you, and let's enjoy the song, and then we come back to our original topic. Thank you very much. Thank you Mahbubul Alam, and thank you all. Let's enjoy the song, and I'm waiting to connect you all. Rohit Mullah, thank you very much. I don't know you understand or not, but you can enjoy. Those already connected, please share on your wall and watch party so that everybody can enjoy. much. Thank you for your patience. Many already joined. Thank you, welcome. Mahbub Alam, thank you. Yes, every day at the startup we try to have a song because any learning, your brain should be diversified from the main other stress because we are passing very stressful time. And thank you, Raju Ahmed. Thank you, Yasin Arafat. And I got a question from Anik, why I run this song. Thank you, Roki Anik, because there is no special requirement that to make you all align, to be easy, to be free, and to be on the topics. That's why we enjoy a song. After that, we start the main topic. So thank you. Welcome, everybody. Welcome, Asif, Arif, Raju, Rohit, Abdul Rashid, Sharif, and many more. I welcome everybody, and thank you for giving me and encouraging me. As per discussion, today is our 22nd class, and you all know that this class is continue every day 10:30 p.m. Dhaka, Bangladesh time. And please, I like to request you can share on your wall and you can like our pages. So today the topic we discuss as per agenda, we are discussing effects of water on preventative different process. And we have discussed corrosion last couple of days, and first 20 classes we have discussed different water chemistry. So if you join first today, I request you please go to our water chemistry live page, and you will enjoy the last 21 classes. Then you can enjoy our today's class. So today we like to discuss especially effect of water and especially scaling. So you see the presentation, or you can see the screen. I'm sure you can hear me clearly, and you can you can see my screen. So water, there are a lot of different effects of water in process. We discussed like corrosion, like scaling, biofouling, biological activity, and different kind of fouling. Thank you, Abdul Khalik. Thank you. So today, yesterday 2 classes, yesterday and day before yesterday, we discussed corrosion. And corrosion was a very big topic, but we try to focus on important that is related to our process. Today I like to highlight it, the first part of scaling. Scaling also a very big part, but I like to discuss scaling maybe 2-3 classes depending on the situation. Assalamu alaikum Aliyaka sir, thank you very much for connecting. Thank you. So today especially we discuss a part of scaling that is very important, consequences of water chemistry, effect of water chemistry on our process. So by the time, if you have any question, you can write me on comments, or you can comments on later also. I try to catch you. Especially I like to speak in English because of the multicultural and multinational people are here. So if you have anything that you really not understand, please let me know. So if you see the picture here, all the effect of the water, if you see here the heavy biological problem, if you see here corrosion, if you see the scaling here, if you see scaling, corrosion, it's a good scale. If you see scale in the pipeline and microbiological fouling, so effects of water is basically synergy. It's a one another integrated. If you have biofouling problem, you might have corrosion. If you have corrosion problem, you will have deposition. If you have deposition, you might have under deposit corrosion. So it's an integrated cyclic process of these things. So today our main topic that we like to discuss is scaling. So what is scaling and how it happens? That's a very interesting and very in-depth effect of water, and this is because of water chemistry. Because of changing of water chemistry, scaling comes. So today I like to highlight a very short part of scaling. So first, what is scaling? Definitely scaling is a precipitated process, or in which salt precipitated and form a layer on any surface comes from a supersaturated solution. So we know different kind of scale, and we know the lot of different salt can precipitate in different mechanism and different fashion. But definitely scaling, if it is a true scale, we will discuss later different kind of scale. But if it is true scale, all the true scale comes because of the precipitation of salt from the supersaturated solution. So it can occur in heated surface or non-heated surface. More commonly on heated surface. Even it can be occur any normal surface also the passage of time because of the temperature, because of change in the pressure, change in the pH, and many other things. So it can happen for related to our system. The scaling can happen in boiling system and in boiler. It can happen in cooling system, in cooler. It can happen RO. It can happen any process where heating, cooling, and evaporation are other process or chemistry changing is over there. So in any system, scaling can be happen where this chemical changes is there. Scaling leads to deposition and clogging and blocking. So if anywhere scaling happen, definitely it create a bigger, thicker deposition, and it block the area, it clog the area, it reduce the flow, and many things happen. Usually when scaling happen, it's a very rare to find only single salt scale. Usually there are a lot of scale happen, and in any scale there are a lot of minerals accumulated. Walaikum assalam, Firoz, thank you very much. Thank you for connecting. I love you to have all this from different corner of the country. Thank you very much. So scaling can be very dangerous, and it is a very common process. So today I like to discuss a bit how scaling happen. And before to understand the scaling process, we have to go through some more understanding about water chemistry. On right side you can see different picture here. I'm sure you can see my cursor on the screen, and you see the different kind of scale, and this is scale environment, that is scaling minerals, and all of the different. We try to discuss gradually. So this picture is for you. Please closely look on the picture. I like to have your answer. Left side there are few pictures, and right side there are a couple of pictures. So let me give answer, or please give your answer. Which one is a scaling and which one is a fouling? So I will be waiting for your answer. Which side is a fouling and which side is a scaling? So you please write on comments. I will appreciate if you write on comments on the screen which side is a fouling and which side is scaling. I will be happy to have your answer. I am waiting for a few seconds. I appreciate if you please write on comments and help me as a participant, that you are also in participating in my discussion. So just write left side is it scaling or deposition or fouling, right side is scaling or fouling. I need your support, and I'm waiting for a couple of seconds for your answer. Rashid, Raju, thank you for joining. Ahmed, Arif, Asif. So you please write. I need anyone answer so that I understand. Mahabubul Alam, I need answer that which side, left side is scaling or right side is scaling. Mollik Chaudhuri, thank you very much. Welcome in our water chemistry live class. So I'm waiting for your answer. Once I have answer, then I will go forward. So I am waiting for your answer. Please at least I need at least 1-2 answers so that I can go forward. My question is, you can see the screen, left side and right side, two group of a picture. Which side picture is scale and which side picture is fouling or microbiological problem or biofouling? I need the clear. You must understand the difference between scaling and fouling, scaling and pure deposition. So I am waiting for your answer. Which side picture is scaling and which side picture is biofouling or deposition? I'm waiting for your answer, guys. Please help me write comment so that I can understand. Firoz, Rashid, Arif, Asif, I need anyone answer so that I understand that you are actively participating with my class. As it is a live class, so I need active participation. I need your help because if you reply, then only I can understand you are on the right track. I'm waiting for your reply. Nobody like to reply? Few more seconds. So left side is scaling or right side is scaling, or left side is fouling or right side is fouling. Mahul Alam, Firoz Alam, I'm sure you are hearing me. Raju, Nazmul Hussain, Arif, Asif, anyone, I need your answer. I'm sure you can hear me clearly. Anyone can confirm, can hear me clearly? You can hear my voice, you can hear or you can see my screen. I'm sure I ask a question in the picture, which side is scaling or scale, or which side is falling. Thank you, Arif Ahmed. Thank you very much. Right side is scaling and left side is falling. Thank you. I can go ahead now. Welcome, welcome. Thank you. I have replied. As if you replied, but I can't see. I think you please, if anyone write to comment, reply on the water like chemistry live. Thank you very much. Thank you. So your answer is correct. So left side is falling and right side is scaling. So we have to be understand very clearly what is scale and what is falling or what is not true scale. So to understand scaling, I like to show you a video, and that video give a very good idea. And please imagine you like to enjoy the water. So right now I like to run a video. On that video you will understand how a salt, any salt, dissolve in water. Because to understand scaling, how water keep the salt soluble in the water, that mechanism is must be very clear to us. So once we understand how salt dissolve in a water and how water keeps the ions inside its structure, then only we can understand how difficult it is to keep the solute inside the water. So first, it's a self-explanatory. There will be a sodium chloride salt. So we know that sodium chloride have sodium ion is a positive ion and chloride ion is a negative ion. So how as a water keep sodium ion hide and water keep chloride ion hide inside the water that we can't see in a visible eye. So let's enjoy the video, then I will explain one by one. Welcome Shariful Islam, welcome in your class. So let's enjoy the video first. This is water molecule. If you see the water molecule, and it's 2 hydrogen 1 oxygen. And if you see the water molecule, the left side is all the water molecule is coming and right side is sodium chloride. So in water molecule, the red part is the positive part and the blue part is the negative part of the water. This is sodium chloride. This is positive. Sodium is the positive part and chloride is the negative part. And if you see water molecule comes and how they attract ions by ions of the salt. If you see the positive part of the water attract the negative part, and negative part the water attract the positive part, and number of water molecule comes together and across, you see they made a group. The positive side of the water surrounded chloride and the negative side of water surrounded sodium. So in this way, a couple of group of the water molecules attract and catch and hide part by part of the ion of the salt, and the total salt become dissolution and become in a solution, and within a couple of seconds or within a minute we can't see any salt in the solution. So on the video, what we understand that water works as a group. Water works as a group, and the positive side of the all water surrounded the negative ions, and the negative side of the water molecule surround the positive ion, and that create that hide the ion of the solute that comes in the water. So this is how water keeps any salt soluble or any in a solution. So now we have to understand few terms, few concepts to understand scaling, and that terms is very easy. I like to make the things very easy for everybody, for every discipline people, so that they can understand. So come with me. Just I try to make these things very easy and clear. First, solute. So for any solution we need a solute. Like the first video here, sodium chloride is a solute. Solute is a salt which is dissolved in the solution. Then solvent. We need to understand what is solvent. Solvent is the media or carrier. Here water is the solvent. Then solution. So when salt and solvent mixed off and the dissolved in the solvent, then they become solution. So it is a blended or a mixture. Then the term we need to be understand, that is solubility. So solubility is any situation or any condition like a fixed temperature, fixed pH, the ability of the solvent to dissolve or hide the salt. So any temperature, any pH, a fixed amount of a solvent can hide or dissolve a fixed amount of salt. That is called solubility. So I am sure everybody understand this very important concept. If you have any question, you can ask me. Welcome Rupok, Chaon, thank you very much. We are discussing water chemistry. This is our 22nd class. We every day discuss on live water chemistry, 10:30 p.m. Dhaka time. Welcome, I'm sure you can enjoy it. So next term that we need to understand, that is called saturation. So once any solvent has a solubility capacity or ability to solve, saturation is a point exact amount equal to ability to hide or dissolve. Or the means that the ability, like in any situation, any water, if it can dissolve 100 gram of sodium chloride, if exactly it dissolve 100 gram of sodium chloride, then that point is called saturation. That point is called saturation. And once a saturated solution, because of pH increase decrease, because of temperature increase decrease, if a saturated solution can dissolve more solute than saturation level, and that solution called supersaturated solution or supersaturation point. Like any excess amount ability to hide, excess amount over the ability to hide or dissolve, if a solution even dissolve this amount, then that solution is called supersaturated solution. This is very important. I will do explain more on with the picture just a bit later. Then we need to understand what is nucleation or seeding. So if any supersaturation solution, generally supersaturation solution can't stay long time. It's a very transition phase, or it's a very unstable phase. So if any solution is stand on supersaturated position because of any reason, if anything happen like any seeding, any other ions comes in or any changes happen, then the first the salt that come out as a precipitated, and that first salt come out as a precipitated, that called is nucleation, that called the seeding. Sometimes we have to add something, that is also called seeding. So because of the seed, some ions, some salt might come out from the solution, and that is called nucleation. And that is the first salt come out from the solution, or we can say from a supersaturated solution. The first salt that come out from a supersaturated solution is called nucleation, or you can say nucleus, or you can say first precipitate mineral. So once the first precipitate mineral come out, when nucleation happen, then couple of this kind of mineral come out, and they combine, and they make a good regular defined shape. And the first shape is called the unit cell, and the first unit cell from the first group of salt come out from the solution. And if a united group, maybe couple of group work together and become a bigger size, and then it is called crystal. This is very important to understand, and I try to explain step by step. So if you have any question, I like to pause for a few seconds for your answer. So if you have anything difficulties to understand all this concept from starting from solute to crystal, I am very happy you can understand scaling very easily. And this is the process. If you see the start from here to here, scaling step by step. So if you understand all the concept, all the terms by the time, so I'm sure you are already understand, and you can easily understand, going to understand scaling. So if you have any question, you can comment on. Thank you very much. I'm sure you are very smart and you can understand very easily. Now this is very important picture. I like to give you an example. Consider this is a solution. I'm sure you can see my cursor. This is a solution, and in that solution we know at this fixed, everything fixed like 25 degrees centigrade temperature, this amount of solvent can dissolve, we know that from literature, can dissolve 100 gram of solutes. So we just pour 100 gram solute. So very first beginning 5 gram already dissolved, and 95 gram here we can see it is still dissolving, means it is started process. We saw the video, we have seen the video. So in that video process, it takes some time to hide all the ions inside the water molecules. So 5 grams just dissolve and 95 gram is still dissolving. So this kind of situation, this solution called unsaturated, means this solution dissolve only 5 gram of solute, but it can dissolve 100 gram solute. So still it can dissolve more and more. That's why this solution is called unsaturated solution. So this is unsaturated, means still it can dissolve more solute. So this is unsaturated solution. So if we wait and wait, or if we stir it, so we can see the more solution and more salt can be dissolved. And here if we see the 91 gram dissolve and 9 gram is undissolved, 9 gram still remain, and still temperature is 25 degrees centigrade, and it becomes equilibrium. Equilibrium means now it's stable, there is no more solute can dissolve here. That means 91 gram is its saturation point, but still we add 100 grams, so 9 gram is still remain in the solution at the 25 degrees centigrade temperature. So at this situation, this solution we call dynamic equilibrium. That means this solution cannot dissolve at this temperature more than 91 grams. So 9 gram remaining as a solute and 91 gram is disappeared within the molecule of the water. So this solution we call saturated solution. If you see, interestingly, if we give heat slowly, on the solution, and we should not lose any amount of solvent, the solvent amount remains same, then this 9 gram also disappeared, and temperature come at, let's say, 50 degrees centigrade. So at 50 degrees centigrade, this solution already dissolved all the 100 gram solute. There is no salt or no solute remain here. So again at 50 degrees centigrade, this solvent or this amount of solution may dissolve more solution, more solute. So at 50 degrees centigrade it becomes again unsaturated solution. That means it can dissolve more. So because of increased temperature, the solvent increase its solubility, they increase its capacity to dissolve more solute. So here the solution was saturated, and again if we increase the temperature, the solution become unsaturated. Now the interesting things happen. This is unsaturated solution. So if we cool very slowly, we don't go very fast, but if we cool very slowly, and if we come down this solution again at 25 degrees centigrade, at very small amount of time, the again 100 gram of the solute still remain in the solution. But we know at 25 degrees centigrade the equilibrium is 91 gram and 9 gram, but in here at 25 degrees centigrade 100 gram is already dissolved. So this solution we call supersaturated solution. Guys, you are understanding me? So this is called supersaturated solution, means here 100 gram is already dissolved here, but it can dissolve at this temperature 91 gram. So it already dissolved 9 gram more than its ability, in its capacity. So this is called supersaturated solution. And if it is cooled further, and if you keep, and automatically it comes down at equilibrium, and it come down at saturated solution, and what it will do, it will just precipitate 9 gram of this solute. That means it comes again at 25 degrees centigrade from supersaturated to saturated solution, and the 9 gram salt come out from the water, and that become precipitated. And that is exactly same thing happen in any cooling and heating system. With the change in temperature, the solution, the solute may be the same, but with the change on the temperature, at some temperature solution become supersaturated, and some temperature solution become undersaturated. For some salt, solution become supersaturated. For some salt, solution become undersaturated or saturated. So that is the change in mechanism, change in the solution concentration, solution capability, or as per solute solubility, the solution becomes sometime undersaturated, sometimes saturated, sometimes supersaturated, again come back to saturated, again come back to undersaturated. So this is happening in our system, like boiling, like cooling system. So guys, if you have any question, you can write on comments. I'm sure I try to explain in very easy way, and maybe if you have any question, you can come. So what are the things that can affect solubility? Definitely from here we understand one of the important parameter is temperature. So temperature always affect solubility. So if you see the graph here, there are different salt like sodium nitrate. There are a lot of different kind of salt. So if you see the graph here is different. Like the temperature increasing here, solubility increasing here. So if you see the graph, some of the salt increase their solubility when increase the temperature. Some of the salt decrease their solubility when increase the temperature. So here we can classify the solubility as two types. One is the increasing solubility, means when temperature increase, solubility increase. You can dissolve more salt in that same solution. But for some cases, when temperature increase, the solubility decrease of the salt, especially like calcium bicarbonate. So if temperature increase and solubility decrease, that means the solute like to come out from the solution, and solution becomes supersaturated when the temperature increase. So if you see the another graph, this is for calcium salt. If you see the temperature increase, the solubility decrease. That means if the change in the temperature in any system, the solution become undersaturated to saturated to supersaturated, and again some solute when comes out, it again become undersaturated. It go another cool area and come back again another the heating area, and temperature increase, another again it becomes supersaturated. So it's a cyclic process happening in the water. If you see the pH, similarly for calcium salt, if you see the pH above 7, if pH increase, the solubility of calcium salt decrease. So same way, if pH increase, the solution becomes saturated, supersaturated, again some solute can come down from the water. So this is how temperature and pH and many other factors also that affect the solubility, and solution becomes supersaturated and scaling can happen. I'm sure I try to explain in very detail. So now come to the scaling mechanism. So guys, I like your permission. It is 11 p.m. Should I continue more time or I should stop? Please, you can write. If you like, then I can continue more couple of minutes. Or if you like to, you should discuss tomorrow, I can stop here. I like someone write. Should I continue 5 more minutes or I should stop here? Because my commitment, I will continue up to 11. And right now this is 11. So if you like, I should continue more 5 minutes. So I will continue. Please comment, should I continue more 5 minutes or I should close for tomorrow? I can wait for tomorrow. Can anyone please write? Should I continue? Okay, thank you. I will continue for another 5 minutes. Thank you, Arif. So if you see the scaling mechanism, so for any water or anything, there are a lot of mineral and different kind of salt always present in our water. It can be cooling water, it can be boiling water, it can be any water. So first what happened, if you see there are we already understand that in a solution, the solution become first saturation, then become supersaturated, then become undersaturated or something like this. So for very beginning, the scale is started from the different kind of precipitation, different kind of dissolution. In some molecules are in the water as a dissolution form, and when nucleus is started and there is some contact time. So all of the factors that help scaling formation. If you see another picture here, like an undersaturated solution. If you go to the zoom picture of the any point of a solution, you can see here something like this. The solution salt is here, and the salt come out, and the salt come out in a solution, and gradually all the salt ions or salt molecule disappear. Thank you, Aliaka sir, thank you very much. So here, if it is saturated solution, if you see the most of the salt remain finished, so all the salt come out in the solution. And if you see the super saturated solution, if you see the all about the solution, all the solvent, all solute already distributed properly, and whole the solution, if you see the color here, this is the solvent color, the color is become more deeper, and it become more deep. So any super saturation solution, there is a equilibrium, and if any region like any seed crystal or any foreign material or anything like pH change, temperature change, it become again solute become precipitated, and big solution become again super saturated. So this is the pure mechanism of any solution to become form a precipitation and scale. If you see more picture how scaling mechanism happen, and if you really enjoy it, you can make a sugar solution, like the way we make a sugar to some crystal sugar. So you can see picture here. The solution, if any super saturation solution, it look like very clean, very clear, but if it is sitting started in the solution, the crystal is started very fast. When the crystal started the crystallization process, and all the solution, the solute become crystal. For our cases, like if I like to explain any water system, or like a cooling water system or boiling water system, where scaling happened, the scaling mechanism is started from the first the ion pairing. Like any solution, there are negative ion and the positive ion. So I can explain, like for an example, as a calcium bicarbonate. So when calcium bicarbonate dissociated, and water have like calcium bicarbonate dissociated, and it become calcium and carbonate and something else, then carbonate and calcium, if they are come at a favorable pH or favorable temperature, like if temperature is above the normal saturation point, then calcium becomes super saturated solution. And if they get any favorable pair of negative ion, like for calcium can be carbonate, so first they like to be pairing, ion pairing, because they like to a partner, because any salt, if it is ionic form, can't come out from the water, because water are very smart, and water is a kind of positive and negative charge. So as in the ionic form, water does not allow to be connect with the other water molecule, the charge opposite charge side of the water molecule, they always try to keep attached with the charged particle or ion in the water. So that's why if any charged particle likes to get out from the water, or like to avoid the water molecule group, it must have another pair. Like if it is a positive charge, it must have a negative another charge, who can combine together and avoid the water group, and they can come out from the water. So first they need a pairs, that is called ionic pairing. Like for calcium ion, it's waiting and looking for carbonate ion. If calcium and carbonate come in an environment that is favorable for them to combine, so they become a pair. So first they prepare, or they make a ionic pairing. So when they come out as take like a marriage, when they decide to get married, then calcium and carbonate become pair, and then they become pair. The couple of pair come together, and they become a small size, and that is started aggregation. So that couple of pairs become aggregation. You can say couple of jugal. So then when it is aggregation and become a little bit very tiny bigger size, that process is called nucleation. And if the size increases and their group increases, and then that become a unit cell. And after a couple of unit cell, because our most of the process is cyclic process, same water is recirculating again and again and again. So with the cyclic process, it become increased. Shahada, thank you very much for joining. We are at the end. So today we are discussing scaling, especially effect of water. Right now we are discussing scaling mechanism. So you join, you continue, and you can later you can enjoy the first what we discussed. So here if you see the couple of nucleation and couple of this small unit cell combined together, and environment is here, then it becomes first crystal and a definite cubic shape. If it is a calcium carbonate, so calcium carbonate usually form exact perfect brick shape or kind of a cubic shape. And if the cubic shape is still, the process is here, nobody interfere here, and nothing can change their structure, and nothing can inhibit this process, then this unit crystal or unit cell combine together like a brick, one brick, another brick, another brick, another brick, and they become crystal. And the crystal started growing and further growing and further growing, and it becomes a layer on a surface, and then it become a scale. So this is how scaling happening in any system. So I will not take more time today. So this is the point I like to close for today, and tomorrow I like to discuss further more from this slide, and how what are the things that influence scaling, and what are the different kind of scales available, and how this different type of scaling can happen in the water. I am welcome you all again tomorrow 10:30 p.m. so we will discuss further. So thank you very much, thank you for watching. I give a minute of time today. If you have any question, please you can write and comment. I will wait for you for a minute, then I will reply for your question, then I will close the call. So if you have any questions so far we have discussed today, you can write and comment, and I welcome, and I am really pleased and grateful to you all. Ali Akka sir, Shahadat Hussain, Ahmed Arif, Rupok Singh from India, Rohit Ali Mullah, thank you. Firoz Alam from Jamalpur, Asif Iqbal Dhaka, Mahu Alam, thank you very much, and Chaudhuri, and many more. Thank you for, because of your inspiration I continue the class, and this is very important technical class. So I like you all. Please share with your technical team, share the colleagues, share your friends, share your people who are working in the industry, so that they can spend a good quality time in this very stress corona period. So this is as our circle of influence, circle of control that we can do now, because all are in the house, all are in the blockade, so we can't do outside anything. So I thank you and appreciated everybody. I like to have you your encouragement. So please do share, like our Water TV page, join our Water TV group, and join our Facebook and YouTube channel, subscribe, so that we can have more people connected and we can continue this class. So if you don't have any question, so I can close today's call. Saim, welcome. Imran Hussain, welcome. So we are at the end of our class for today. 10:30 we started, 11 we are going to finish. So I welcome you again. Please join 10:30 tomorrow, same time, on the same page, Water Chemistry Live. By the time, I request you all, stay safe, stay connected, and be happy, be in a good mood, do self-study and enjoy your life, and make yourself more strong. Be aware, don't go out, but stay safe. Thank you very much. Thank you. Assalamu alaikum and good night. Bye bye for today. Thank you. Assalamu alaikum.